So as for integrated 2, this is your factoring review. Hopefully have a variety of different things on here. Here we have our list of need to know, and I tried to do it in the order in which I would approach a problem. So if there's a GCF, always factor it out, makes your life easier. If it's a binomial, so now we determine how many terms we have. If it's got 2 terms, try to see if it's difference of squares. If it's 3 terms, then that would typically be your boxes and your diamonds. But you do need to be able to make sure that you can do the ones that are more complicated. So if you have a leading coefficient of 1, so that would be like a 1x squared, or if you have a leading coefficient that isn't 1, you need to be able to do it with or without a GCF. And don't forget there's also the perfect square trinomials. However, you don't necessarily have to know that pattern. Actually, you don't even really have to know difference of squares. You can go through and do the boxes and diamonds on everything. And then don't forget, you always have to factor completely. Okay, so here we've got some questions. What I decided to do, or tried to do, was start with like entry-level type factoring problems and then progressively add like a little bit of a twist to them. So maybe make them just a tiny bit more challenging. So on this first one, I will go through a couple of them, but then my recommendation on most of these, because we've gone through and done all of these types of questions in class, would really be to use this as like an interactive worksheet. So pause the video, really even before I start doing this one if you want to use it as a practice. And then when you're done, come back and check your answer. Look at the work, see if you get the exact same thing. But for this one, I am going to go ahead and go through it instead of just kind of plopping down the work. So as a reminder, I take a look at this. First thing, is there a GCF? Well, yeah, it's 1 though. So if you factor out a 1, that doesn't really do anything. So GCF, yes. Does it do anything? No. Okay, so let's move on. How many terms do I have? I have 3. If I have 3 terms, I'm going to look to see that it is a quadratic. So I want it to be x squared, x, constant. And I want it in that order. So, which I do have. All right, so no GCF. It is in descending order, so x squared, x, constant. All right, I'm going to go ahead and start setting up the area model. So again, this is just a tool. You do not have to use this to factor. Take the first term, so take your x squared term. That's going to go in the bottom left-hand corner. Then go back to the question, grab the constant. That's going to go in the top right-hand corner. You just want to make sure that those two are in opposite corners of each other inside the generic rectangle. Okay, so now, using the idea of this pattern that we have established, if I multiply these 2 along the diagonal, that's going to give me the top of the diamond that I'm going to use. So if I multiply those 2, I'm going to get 36x squared. All right, so let's set up the diamond now. Again, just another tool though. So when I multiplied, I got that 36x squared. Okay. Now we have to figure out how we get the bottom of this diamond. Well, the bottom of this diamond, go all the way back to the quadratic that you're trying to factor and grab the x term. So that's the 15x. That goes in the bottom of the diamond. Now, as a reminder, the bottom of the diamond represents the addition. The top of the diamond represents the multiplication. Well, the only way to get the x squared and the x is these are going to have to be x's just to make that happen. So once we've handled that, now we can just move on to, well, how do I get the 36 and the 15? So you can start going through and making a list. So let's see, the first thing that goes into 36 is 1. So we've got 1 and 36. That's not going to work. 2 and 18. That's not going to work. That gives me 20. 3 and 12. Oh, that works. 3 and 12 gives me 15. Now I'm going to take those items. So those 2 things that we just found, so that 3x and that 12x, they go into the empty boxes. Now, it doesn't matter which one goes where, just so you know. Really doesn't. So we had a 3x and a 12x. Now from here, we're going to factor. So one of the ways that I talked about it in class was to go through and just kind of ignore a section. So I think I'm going to ignore this right-hand side just for the time being. And I'm going to take a look at this column here. And I'm going to ask myself, what could I take out of an x squared and a 3x evenly? So like a GCF. Well, I think I can take out an x. You'll notice that that x squared and that 3x are stacked up as a column. So when I pull out the x, I want it to be at the bottom of that column. Once you have one piece, you should be able to find the rest of them. So I'm going to go through and just kind of ignore sections. So if I have a base of x and an area of x squared, then that means that the height of this is going to be x. So just go through and keep ignoring some stuff. So if we ignore that, I know the base of that rectangle 3x is x. I know the area is 3x, which means the height of that box is going to have to be a positive 3. And then we just need to find the last one. And you can do this a couple different ways. So I'm going to ignore that section there. I know that the area box, 12x, has a height of x, which means it's going to have a base of positive 12. Now, the last thing I need to do is actually rewrite this as a product. So I'm going to take the base of the rectangle, which was x plus 12, and I'm going to multiply it to the height of the rectangle, which is x plus 3. Whenever you factor, always inspect and see if there's anything else that you could do. So I'm going to look inside the first set of parentheses only. I'm going to ask myself, could I factor out a GCF? No. How many terms does it have? It's got 2. Is it a difference of squares? No. Okay, there's nothing else I can do with that one. Look at the second one, ask yourself the exact same questions. I think it's a whole bunch of no's on that one as well, which means my final answer is that factorization, x plus 12 and x plus 3. Now, question 2 and question 3 are identical to this one in that it's the same process, but the numbers are a little bit different. So I would pause right now if I were you, try question 2, and then unpause and come back and take a look at the work and see if you got the exact same answer. And then we'll do the same process for question number 3. So double check yours against mine. I did go through and draw the generic rectangle and the diamond problem to help us out here. And then put in the 2 things that I found into the 2 opposite corners and pulled out the GCFs from each column and row. Let's try the third one now as well. So pause at this moment, come back, see how you did. Okay, so there's our complete factorization for the third question. All right. Moving on. Question 4, 5, 6. Let's take a look at these. So remember I said that I was going to kind of up the, not difficulty in it, but just kind of like a little tweak each time. So first thing, always, GCF. Yes, actually, I think I can take something out. If I take a look at the numbers 3 and -5, that's a 1, so I can't take anything out of there and change the problem. But I can with the variables. I have an x squared and I have an x. I think they can both give up an x. So I'm going to go ahead and take my GCF out, open a new set of parentheses, and now I'm going to divide. So basically, what I'm doing here off to the side, so here's my scratch work. I'm taking 3x squared and I'm dividing it by x. That's going to give me a 3x. That's going to be the first thing that goes inside. Then I'm going to take the -5x and I am also dividing it by x. That's going to give me -5. That's going to be my second entry. Close the parentheses. Okay, now every time I factor, remember, check is parentheses. If it's just an x or a GCF out in front, there's not going to be anything else that we can do to factor it. It's things that have more than one term. So I'm going to take a look at the 3x minus 5. And I go through the process. Does it have a GCF? Well, sure, it's got a GCF of 1, but that doesn't do us any good. So does it have how many terms? It's got 2. All right, is it a difference of squares? Nope. Okay, I think we're done. Sometimes the only thing you can do is take out a GCF. All right, let's take a look at question number 5. Again, keep adding a little bit of a wrinkle to everything. All right, GCF. Yes, actually, I think I can take out numbers and variables. And like I said in class, I really like to have the leading term being positive. So I think I'm going to divide both of these by -8. But then, so I'll put my -8 out in front. I think I can also take out an x. So I've got an x squared and an x. So I think I'm going to divide out a negative 8x. All right, so I do my division. So negative 8, so my first term. First term, negative 8 divided by negative 8 that I'm taking out is 1. X squared divided by x is x. So I'm going to have an x. Then I move on to the next one. Positive 32 divided by negative 8. That's going to give me negative 4. X divided by x, that cancels. All right, so pulled my GCF out. Now I'm going to inspect the parentheses inside. Is there a GCF? Sure, but it's 1, so that doesn't do me any good. How many terms does it have? Well, it's got 2, so is it a difference of squares? No, it isn't. I think that's it. All right, number 6. Number 6. So I'm going to go through my process here. Is there a GCF? Well, pulling out a 1 is possible. So GCF of 1 doesn't do anything. We have 3 terms, though. So this is just like what we did on the first slide. So take this minute, see if you can factor it, come back and check your answer. Okay, so this is what I got from the boxes and the diamonds. I did already go through and check each term, too. So I looked at the 2x plus 1, GCF, 1, but yeah, no. So 2 terms, difference of squares? No. All right, can't be factored any further. X minus 4, same process. No GCF that could help me. 2 terms, not a difference of squares. Okay, moving on. If you take a look at question number 7, it's a trinomial. And just see if you can go through, do that one, come back and check your answer. So there's the solution to 7. Let's see if we can do number 8. So I recognized a pattern on this one, which is that perfect square trinomial. Remember, you don't have to do it this way, but it will work. So what I noticed is this. If I take the first term, that is the x squared, and I square root it, I'm going to get x. If I take the last term, it's got to be positive, and I square root it, I get 5. Okay, following my pattern. I'm going to take those two guys, take those two and multiply them together. So multiply those two together. That's going to give me a 5x. Double it, match the sign from the middle, and then I check, does that negative 10x match that middle term? If it does, this is a difference of square, or excuse me, this is the perfect square trinomial. So I'm going to take the 2 items that I got when I square rooted. So I got the x and I got the 5. I'm going to put them inside the parentheses in that order. So x and 5. Then I take a look back at the sign on the middle term. So the sign on the 10x, so the guy in the middle, that was my minus. Those are the signs that I put inside the parentheses. The parentheses are going to match. They're going to be identical. So then if you take a look, we have that minus sign. We have the x and the 5. And then since they're going to match, we're going to have a squared. So what's in the red box is my answer. You get the exact same thing if you use the diamonds and boxes. Okay, question number 9. On question number 9, first thing, GCF. Yes, absolutely, there's a GCF. It looks like I can take out a 2. So let's factor out a 2. And then that's going to give me a 2x squared minus 7x minus 15. Now, just like we did on the previous problems, you inspect the parentheses. Is there any way I can factor that? Well, GCF, no, we already took it out. 3 terms, okay, maybe the diamonds and the boxes will work on this. So go ahead and set up the diamonds and boxes just on the thing on the inside. Leave the GCF out of this. Now that I've completed the boxes and the diamonds for this, I'm going to go ahead and rewrite my answer. Remember to carry your GCF of 2 with you. So put it in front, just like it was before. Now, base and height. So base of 2x plus 3, height of x minus 5. Inspect the parentheses again. 2x plus 3 cannot be factored anymore. X minus 5 cannot be factored anymore. So the whole thing, including the 2 out in front, is going to be our factorization for question number 9. Okay, last 2 questions here. You'll notice that I transitioned us now directly to the two terms. We're still going to look for a GCF. That's not going to change. So on question number 10, no, there's no GCF other than one. How many terms? 2. There's 2 terms. Okay, I'm going to see if this is a difference of squares. So I'm going to take the first term and I'm going to square root it. That's an x. I am going to acknowledge that I have a negative sign, which is technically in this case, I'm going to treat it as a subtraction. Then I'm going to look at the next term. That's a subtraction, so that's not part of my term at this point. I square root the 100, I get a 10. And I do have a minus between them. All right, I'm ready for this. So I'm going to open 2 sets of parentheses. I'm going to take the x, which was the square root of the first term, and put it in first. I'm going to take the 10, which was the square root of the second term, and put it in second. Now, the only way to satisfy the minus sign, which I'm now going to kind of transition my thought to be a negative, the only way to get a negative is if the signs differ. So one of these is going to have to be a plus, and the other one is going to have to be a minus. Do a quick check. Can I factor x plus 10 any further? No. Can I factor x minus 10 any further? No. And the parentheses don't match exactly, so you can't crush them together and make it like a squared on the outside. So this is the best that we can do. Okay, question number 11. First, is there a GCF? Yes, there absolutely is. There's a 3. I can take that out. You could actually even shuffle these around if you want, but you don't have to. So since we've kind of gotten into the habit of making sure that the x squared comes first, I think I am going to go ahead and reorganize this. Again, not that you have to. And then I prefer to have a positive number on my x squared. So I'm going to divide out a negative 3. If I do that, that's going to give me a positive 9x squared and a negative 4. Look inside the parentheses. GCF? No, other than 1. 2 terms. Okay, let's check and see if this is a difference of squares. So I'm going to take a look at the first term. I'm going to square root that. That's going to give me a 3x. I do see that I've got the difference part. That's good. And then I'm going to square root the last term. And that's going to give me a 2. All right, here we go. Carry the GCF with you in front. So the negative 3. Open 2 sets of parentheses. The first square root was 3x, so put that in first. The second square root was 2, put that in second. The only way to get the opposite sign, or the negative sign here, is that they have opposite signs. Do a quick check on your parentheses. 3x plus 2, nothing I can do. Can't take it a GCF. It's 2 terms, but it's not a difference of squares. All right, take a look at the next one. No GCF other than 1, 2 terms, but it's not a difference of squares. I think that we are done. And that's your review for this essential skill.